All right.
So,
The floor is yours.
thank you. So, my research was basically a review of blue light and its structural and functional effects on children's brains and neural development. So, some background about me is my name is Pranauv. I go to Mountain House High School, which is in Mountain House, California, and I'm a senior, so class of 2024. So, just so like to know what I'd be going over today. So, first, I just want to understand blue light first. So, before we get into its effects on brains and neural development, just a quick understanding of blue light. Then we'll go into its specifics, such as circadian rhythms and melatonin suppression. Finally, we have the retinal cells and visual perception. And then I want to specifically talk about its effects on children and neural development. And finally, I'll be going over some recommendations and preventative measures. So first, before we go into specifics, I want you guys to understand blue light. So blue light is part of the visible light spectrum, and when I say this, I mean that it's within the 400 to 500 nanometer range, and it's characterized by its high energy level and short wavelength. So blue light, we can get exposed to it through many sources, but the three main ones are sunlight, digital screens, so maybe your phone, your computer, stuff like that. And finally, light emitting diodes, which we know as LEDs from LED lights and stuff of that nature. So, scientists have been interested in the effects of blue light for decades, and they found many positive and negative effects from blue light. So, when we look at positive effects, it plays an active role in melatonin suppression, which I'll get into later, increased cognitive performance, which I'll also get into later, and then alertness, which just makes us feel alert. And the negative effects are it has a lot of implications on sleep quality. It can cause damage to our retinas and our eyes. And finally, it can also cause disruptions in circadian rhythms and circadian cycle durations as well. So now when we talk about circadian rhythms and melatonin suppression, so before I talk about blue light's effect on them, so I just want to go over circadian rhythms and melatonin suppression as a whole. So circadian rhythms are basically 24-hour cycles that are part of the body's internal clock. And these serve to carry out necessary biological processes in the body. So basically, it tells us like when to sleep, when we feel sleepy, and when we feel awake. And melatonin is basically what helps regulate circadian rhythms. It's like the driving factor behind it. And this is basically a hormone secreted by the pineal gland, and it helps synchronize the sleep-wake cycle. So basically, it helps you know when to wake up, when to sleep, and stuff like that. So blue light's effect on this. So blue light, it doesn't negatively affect it as a whole. It's basically when you're exposed to blue light that causes the effect, basically. So let's say you're exposed to blue light in the morning. So you wake up and you use your phone or you go out in the sun or something like that. And your melatonin, which is secreted by the pineal gland, is suppressed. And this leads to effects in circadian rhythm. And since it's the morning, you feel more awake and alert and you have increased cognitive performance because you feel more awake. So in this case, it is a positive effect because you're ready to take on the day. But at the same time, if you're exposed to blue light in the night, and this is basically since there's no sunlight or anything, it's basically from tech devices before sleeping. So if you're on your phone before you sleep or you're on your computer before you sleep, this still causes the suppression of melatonin just like in the morning, and it leads to effects in circadian rhythm. But now it's a negative effect because the body feels awake, and this leads to implications in sleep quality because you don't feel like sleeping even though it's the night, you know? And thirdly, we have its effects on retinal cells and visual perception. So blue light is harmful to eye tissue because of its high energy level and that short wavelength, basically from the 400 to 500 nanometer range of the spectrum. And since blue light technically it is increasing popularity because of all these technological devices we have now, the effects of blue light are becoming more prominent in humans and it's becoming a prevalent concern, especially for eye quality. So blue light's effects on the eye, there's mainly five effects, all of which are negative. So the first one, it contains a delay in corneal epithelial cell development. It can lead to dry eyes. It can cause a loss of stability of the tear film, which is right around this where my cursor is. It can also cause retinal photochemical damage, which was the main like negative factor. And it can also increase your chance of developing cataracts later in your life as well. So when I want to get into a little more specific with children and neurodevelopment, because I feel like they have the highest chance of turning it around basically. So I did some research on brain maturation. So Kosevska and colleagues from a paper in 2016, they conducted a prospective cohort study that revealed that sleep disturbances from age 2 onwards are associated with smaller gray matter volumes in the brain. And basically what this means is that sleep disturbances, they can interfere with and potentially delay the maturational process of the brain. Just like your arm or leg or any other body part develops as you grow older, the brain also needs to develop and mature over time. But if sleep disturbances can interfere and potentially delay the maturational process of the brain, and blue light is correlated with a lack of development, this is a straight like negative correlation. Also, when we talk about learning problems and disorders, so when the circadian rhythm cycle is disrupted, it can have implications on children's ability to learn, and it can lead to learning problems and disorders as well. So prior studies have suggested that sleep loss is frequently associated with poor declarative and procedural learning in students, and that restricted sleep, mainly meaning less than recommended, can lead to a worsening in neurocognitive and academic performance. And finally, I want to talk about some recommendations and preventative measures to protect us from blue light. And like I said before, blue light isn't a bad thing, it's just when you're exposed to it. So I wouldn't use these preventative measures in the morning, but I would take them into consideration during the night when it is not a good thing. So first, you have blue light blocking amber glasses as well. And these advance circadian rhythms in patients with delayed sleep phase disorder, and they enhance individuals' abilities to sleep. And then finally, we have blue light filtering intraocular lenses, or IOLs for short. And these are tiny surgically implanted lenses in the eye to filter shortwave blue light from reaching the eye. And these allow individuals to experience an overall better quality of vision, reduced glare disability, and protection from retinal phototoxicity. And thank you. So if you have any questions, you could ask them right now, or you could go to my email as well. Thanks.
This is a really fascinating topic. Just because, just in thinking of the last 15 years with the number of smartphones and
Mhm.
iPads and all these things, especially nowadays, kids are using iPads for education programs and learning programs. So there seems to be sort of um, it's almost like counterintuitive, I guess, where you
Mhm.
have kids are learning on an iPad, but it actually, as you said, contributes to
Mhm.
developmental delays. My question to you, um, as I was listening to your presentation, is what are the recommendations for children nowadays? Like, when can they start using iPads or other computers that have blue light?
Mhm. So it's not really like how much of blue light should I be exposed to? It's basically when. It's more of a factor of when than like the what. So
Hmm,
personally, for children, I'd say maybe just 2 hours before their bedtime or before they sleep, just don't give them any electronics. Just make them, be occupied with something else.
got it. And a question that was submitted in the audience here is, what got you interested in this specific topic?
Hmm. So I'm pretty interested in neuroscience and stuff with the brain, but I'm more interested in like what can we do to make our brains process faster and mature faster, basically? Because I see people now, like even toddlers, they're really smart for their age, and I want to know like what are they doing, and how can I make more people of that same age like have that increased capability as well.
Great,
Yeah,
fantastic, great job, Pranav.
yeah. Thank you.
Thanks so much.